All right, problem 6-86. Shift the graph of log x up 3 units and to the right 6. Graph both the original and transformed graph on the same set of axes and write the equation for the transformed graph. First of all, our original graph is going to be y equals log of x. Remember, this is like base 10. Let's pull out our graphing calculator. I'm not going to graph it by hand here because I have the ability to use the calculator, and I think you'll be able to see a little bit better what we're trying to do here. I'm going to go ahead and graph y equals log of x. And this would be like our parent function here. Let's see here. Let's graph it. Boom. So you see it starts and it goes up this way. Okay, remember this is the inverse of an exponential function, which curves upward this way. Let's look now here. They want us to shift the graph up 3 units and to the right 6. Now we've talked about shifting graphs a lot earlier in the year. We haven't done a lot of shifting recently, but we know that shifting it up usually involves k, and shifting it right usually is going to involve h. So let's think about what this equation might look like if it followed the same properties as many of the other ones we had. And let's list a couple of the other ones. Remember we did quadratics. We said y was equal to a times the quantity of x minus h squared plus k, where hk here, that point was our vertex point. This affected the horizontal shift, this affected the vertical shift. And then a, just because this one, remember, it affected the orientation and the shape of it, the width of our parabola. We also had cubic functions, which were y equals a times the quantity of x minus h cubed plus k. And the transformations remain the same in terms of the effects of h and k. And what about there we had y equals, I think, the absolute value. We also had exponential, where we had y was equal to a times b raised to the power of x minus h all plus k. And we've got several more here, but I hope that you're getting the idea. If we're thinking about y equals the log of x, what could we do here? Well, notice our h is always paired up with x, wherever x is. So let's try this. Let's try to rewrite it as y is equal to, and let's just go ahead and throw in a, right? A is always whatever out in front here. It's being multiplied. So let's say a times the log of, our h should fall in here, x minus h. And then we're going to need to close it, and we usually add our k at the end. So let's test the effects of some of these here to begin. Let's say here we want to shift our graph up 3 units, which means we're going to have to change that k to plus 3. So if we're just going to shift it up 3, we're looking at the equation becoming y equals the log of x plus 3. Let's see if that shifts this graph up 3 units. Let's just go into our calculators, go down to y2, and let's do y equals the log of x, and let's close our parentheses, plus 3. Graph it. And sure enough, it's gone up 1, 2, 3. It's gone up 3 units. So this property still holds true. Whatever we're adding or subtracting at the end is going to move it up and down. Well, let's see if the h holds true. We want to shift it to the right 6 units. So we're going to have to plug it in, that 6 for our h. So if we're going up 3 and right 6, let's see here, we're going to do y equals the log of, and if we wanted to go to the right, remember that's going to be like saying x minus 6 plus 3. So this should move us up 3 units, which we've already done there, and then to the right 6. Let's go down here. Let's just do a third one here. Log of x. Oops, we don't want to do, we want to take it there. We want to subtract our 6, close it, then add our 3, and then graph it. And sure enough, we've gone up 3 and we've gone right 6 units. So in order to answer what it's actually asking us to do, let's go back into our y equals here. Let's deactivate that middle one because they didn't want 3 graphs on there. Let's just deactivate that one. Let's graph it again. There is our original function and there is our transformed function. Let's take it, oops, wrong button there. Let's pull it off here so we've got a copy of it. Let's put our calculator away. So here would be our original function. Here's the transformed function. They ask us to come up with the equation for the transformed graph. That would be y equals log of a quantity x minus 6 plus 3. Follows the same patterns and rules as our other functions. If you need it or want to see some other examples, or if you want to play around, if you go to our website, www.wnalgebra2.weebly.com, and then look under the Student tab. There should be a GeoGebra tool for, oops, I gotta spell it right. There should be a GeoGebra tool for logarithms and exponential functions. Allow you to transform them and move them around, play with them a little bit more. This is problem 6-86. Hope this helped you with this problem, answer any questions that you had. Thanks for watching.